Okay, I wanted to mention a couple of problems here for section 3.4 about graphing polynomial functions. And the first one here on this little demonstration is asking about four of these graphs, and it asks which of the graphs cannot be that of a polynomial function. Well, we've already discussed, we know that the polynomial functions, they will have graphs where one end is up and the other end is down. They can either look something like this, where the left goes up and the right end goes down, or we could have just the opposite, left end down, the right end goes up. So that, looking back at the four graphs that we have to select from over here, that pretty much will rule out our letter C, because we see on C that the left end is up and the right end is up. Now on A, B, and D, both of those also, all three of those I should say, have one end up, one end down. However, there's another consideration here. When we do have, let's just put one here. Let's say we've got x cubed minus 2x squared minus 3x. Just to put a function there. If we also think about x-intercepts here, there's another limitation that'll affect our answer as well. When you have a third degree or cubic, at most we will have 3 x-intercepts. And that's simply because if we solve this equation, let the f of x be 0, this one would solve by factoring, but simply put, yeah, you're not going to get any more x-intercepts than what your highest degree is. So a cubic is third degree. You're going to have at most 3 x-intercepts. Well, if you look back here at A, you got 1, 2, 3, 4 x-intercepts, and that's just not going to happen on a cubic. Now B has 1, 2, 3 x-intercepts, so that's okay. And then of course D is 1, so that can happen. You can have less than 3, but you can't have more than 3. So in this particular case, yeah, we're looking at B and D. I'm going to type those in. I might have to do capitals B, comma, D. Alright, let's see. B. Do they want a space there? Oh, B and D cannot be. Oh, I'm putting the ones that can be. All right. All right, so cannot be A and C. A, comma, C. All right. Read the question. That's always important. All right, number 2. Use the given function to answer the questions that follow. F of x equals x to the fourth minus 16x squared. Use the leading coefficient test to determine the graph's end behavior. Okay, so we do have an x to the fourth is our largest degree, so we know on those either both ends go up, both ends go down, and it being a positive leading term, that means both ends are going to go up, so that would be rising to the right and to the left. Rises left, rises right. So f of x equals x to the fourth minus 16x squared. We do know graph-wise that's going to put us both ends going up to start off this graph. All right. Find the x-intercepts. Okay, and so as we know, x-intercepts always the y is 0. But in this case, that would mean f of x is 0. So if we solve that little equation there, both terms have a common factor of x squared. Factor off the x squared. And then x squared minus 16, that as well factors, or we could use the square root method either way. It's x minus 4 times x plus 4. And so we wind up with these three equations. And of course x squared equals 0. Square root both sides, you got x is 0. Add 4 on the middle equation there, you've got x equals positive 4, and subtract 4. And we also have an x-intercept of negative 4. So typing those in, 0, comma, 4, comma, negative 4. All right. Now it's going to ask us, at which of the zeros does the graph of the function cross the x-axis? Well, let me just look at a little bit here, this graph. Expand this out a little bit. Okay, so we have our x-intercepts of 4, negative 4, 0, positive 4 here. And the way I was telling you is look at, to finish this graph off, is look at a couple other values between the x-intercepts. And so between the negative 4 and the 0, obviously a negative 2 and then a positive 2, that would work well as well. And then just figure out the y value, plug those in for x, and see what the y value is that you get. So if I plug in a negative 2 for the x into the function value there, that gives me positive 16, negative 2 to the fourth, minus 16 times, this would be positive 4. So that's 16 minus 64. Net result is we get a negative 48. Negative 48 for the y value. All right. Similarly, if I plug in x to be 2, that would give me 2 to the fourth minus 16 times 2 squared. Well, that's going to give me 16 minus 16 times 4 again, which is 16 minus 64, so I get negative 48 again. And so if I put those points here on my xy axes, let's just say that's negative 48. So at negative 2, I'm at negative 48. Positive 2, I'm at negative 48 as well. And so if I connect the intercepts, the end behavior, these points, here's what I see. All right, well, here's the thing to mention is when I get to the 0 here, I'm not going to go across there. I have to come on this in behavior. I come down and cross over there. But when I come back up to the 0 here, I'm not going to cross over because I need to come back down here to the negative 48. So it just comes up to this x-intercept, turns around, comes back down, and then goes back up, then goes to the in behavior up there. Okay, now back to our question. Because of all that, it asks, at which 0 does the graph of the function cross the x-axis? Select the correct choice below. All right, so zeros, again, that's another word there for x-intercepts. So which x-intercepts does it cross the x-axis? Well, that would be at -4 and +4. It doesn't cross at 0, so that's the answers they're wanting here, -4 and +4. All right, so got those in there. Okay, good. At which 0s does the graph of the function touch the x-axis and turn around? All right, well, we saw that over here on our graph, we got to turn around at x equals 0 because it's got to, hit the -48 up the -2, and then at +2, also -48. So anyway, x equals 0 is that turnaround point that we have. Good. Okay. Find the y-intercept. Well, that's easy to find the y-intercept. You always let x be 0. So if I plug in x to be 0, 0 to the 4th minus 16 times 0 squared. Well, that's 0 minus 16 times 0, which of course is 0 minus 0 is 0. Okay, so the y-intercept would be 0. Check it. Okay. All right. Determine the symmetry. Okay, yeah, another thing that I wanted to mention here. Determine the symmetry. Well, we've got a choice here of even y-axis symmetry, odd origin symmetry, or neither. What that means as far as the y-axis symmetry, if I look at this graph and draw a line right here at the y-axis, or think about a line there at the y-axis, I can definitely see that one side is the mirror image. I got the same on this, either side. I got the same intercept. Well, one's at -4, one's at +4. I've got this -2, -48, and +2, -48. Yeah, these two are mirror images of each other on either side of that y-axis. So that does mean in this case that's going to be this y-axis symmetry. And then, of course, the last step on this one, determine the graph of the function. Well, we've got it right there. We see the one that matches nearest to ours is, of course, D. D is our best answer there. Okay. All right. Let me go on to my third one. Answers A through E. For the function shown below, 3x squared minus f of x equals 3x squared minus x cubed. Use the leading coefficients test. This is A here. Use the leading coefficient test to determine the graph's end behavior. All right, well, just a little bit of trickiness here. The end behavior, of course, is based on the degree of the function. And in this case, the degree of the function is not the first term there, 3x squared, but the last term. It's the largest degree term. So I've got a minus x cubed, so I've got a cubic function. And as we know, on the cubic function, one end is up, one end is down, and because we've got a minus x cubed, we do know this function's end behavior. Draw a little graph here. The left end up, right end down. It's our end behavior. Okay, so they phrase it, the graph of f rises to the left and rises to the right. No, it does not rise to the right. The graph of f falls to the left and falls to the right. No, the graph of f of x falls left and rises right. Nope, and the graph of f of x rises to the left and falls to the right. There we go. D. Be the correct one there. Okay. Find the x-intercepts. All right, so the x-intercepts, we know we do that by setting y is 0, or f of x equals 0. So we have 0 equals 3x squared minus x cubed. And so that is going to be done by a little bit of factoring. We have a common factor of x squared, so we factor that off. We have x squared times 3 minus x. So that means x squared equals 0, or 3 minus x equal 0. Solve those twos. X squared equals 0, square root both sides, or whatever. We've got x equals 0, x-intercept. And then here, if we just add x, both sides, we get 3 equals x. So that's my x-intercepts right there, 0 and 3. X equals 0. And comma, x equals 3. All right. And also, at which x-intercept does the graph of the function cross the x-axis? Select. All right. Well, again, just starting off here, let me get this opened up a little bit. We can work a little bit. Let me go ahead and complete this graph. And what we said, all right, so we've got an x-intercept at 0 and at 3. 0 and at 3. And behavior up on the left, down on the right. All right, let me, in this case, what I recommended was put a little point there in between our x-intercepts. And so here, x equals 1 or x equals 2. Take your pick there. I'm going to go with x equals 2. And then calculate your y value, plugging in that value for x. So I have 3 times 2 squared minus 2 cubed. So that would be 3 times 4 minus 2 cubed would be 8. So that would be 12 minus 8. That would be 4. X equals 4. Sorry, y equals 4. Then it goes with the x value 2. So 2. All right. Okay. So here's what we can say. We've got only the x-intercepts of 0 and 3. We've got the end behavior coming in here. So as we come in to my x value, we've got this a little too far over then, because it's just going to come in right here to this x. Now, the next point I've got in order is up to the 2, 4 value. Well, what that means is I can't cross at that x-intercept, because if I cross the x-intercept, that's going to put me down in the negative side. So it's just going to come around and touch there at that x equals 0 value, then come back up to the 2, 4 at some point, and then come back down and go through, and then in behavior down on the right. So this graph is something in this, looks something to this effect right here. Okay, so back to our question. At which x-intercepts does a graph cross the x-axis? Well, in this case, it crosses the x-axis at x equals 3. It just crosses there at x equals 3. So let me type that in here. All right, and then at which x-intercept does the graph of the function touch the x-axis and turn around? Well, that's what we saw with our x equals 0 value right there. Turn around at x equals 0. All right. Now, one other quick little point here. What we saw is on the previous two, let me see if I can, just to make a point here. Saw a difference between this was the x to the 4th minus 16x squared. That was the previous number 2 one. And the difference here was, well, it was basically, if you look back, we see that on the both of these were at x equals 0. They came from the equation x squared equals 0. In other words, that factor, when I factored it out, it was squared. Same thing over here. I saw, yeah, when x equals 0, I had x squared equals 0. Whereas on the other ones, I didn't have the square, x minus 4, x plus 4, where it crossed at x equals 4 and x equals 3. So that's kind of the key. If you got a factor squared, you're going to have this turnaround point. Just a little bit of extra information there. Okay. All right. Find, back to this one, find the y-intercept. Okay, so we're finding the y-intercept. We've got 3x squared minus x cubed. Find the y-intercept. You set x to be 0. So plug in x to be 0. Of course, that term's 0, that term's 0. So the y-intercept certainly is 0. Okay. Checking. Got it. Okay. All right. So last but not least, I think then, oh, no, got one more thing. Determine where the graph has y-axis symmetry, origin symmetry, or neither. Well, if you look at this graph, there's not any symmetry. If you look at the y-axis, this side doesn't mirror image that side, so it's not y-axis symmetry. Origin symmetry, well, let me just show you one as origin symmetry. And so that kind of thing is what we're looking at with origin symmetry. Where it kind of flips over and then flips back. One way to look at it, if I flip this over and then flip that over. Yeah, that's origin symmetry. That's not what I got. So neither one of those is what I got. And so yeah, all right. So final check there. All right, use a graphing tool, function necessary. Okay, so this one, we want to graph this thing right here if we can. And so that is, of course, our, if you look at all the choices here, we've got to select a line, a V, kind of a U shape, circle, so forth. Well, in this case, yeah, it's the one that kind of goes up and down, the cubic tool, and kind of gives it away there that we've got a cubic polynomial, so I'm going to select that one. All right, and what I'm going to want to put on that, I believe, is a couple of points. I need to put the intercepts, X-intercepts. Got 0, and then I got 3. All right, then I also found the point 2, 4. All right, and so you can see that it's wanting one more point. So let's come back over here to this table. Span that out. All right, and I think probably either this side or this side would be a good one to get another point for our graph over there. So let's just plug in. Let's see what x is -1 is. So if I do x is -1, I'll have 3 times -1 squared minus -1 cubed. So that'll be 3 times +1. -1 cubed is -1, so I have minus -1. So that'll be 3. This and this make a plus. So 3 plus 1, so I have 4. That'll be 4 also. -1, 4. Okay. So this point right here should be also -1, +4. Okay, so keeping that in mind, yeah, back over here at -1, I want there to be a -1, 4 point. Yeah, all right, so does that look vaguely like I had? Yeah, I think so. So let's check that answer, and sure enough, got it. All right. So hopefully that'll help you in your section 3.4 homework.